start?
I'll
I'll start. So I'll be
okay.
okay.
Yes, start.
Hi, welcome to this particular live session, and this is on fabrication techniques for MEMS-based sensors, clinical perspective. I welcome all of you to this particular session. You feel free to ask me any questions that you want to ask. Um, I hope that you are enjoying this particular rerun course, and we have given a quite a bit of emphasis on fabrication techniques for MEMS. MEMS, as we know, it's a micro electromechanical systems, and we never say MEMS sensors. We always say that it's a MEMS based sensor. And there's a difference between MEMS sensor and MEMS based sensor because MEMS sensors are something that requires a mechanical structure embedded or integrated onto the platform. While when you talk about MEMS-based sensors, MEMS-based sensors are using technology that is microfabrication technology for fabricating sensors, but may not involve the mechanical structures into it. However, when we say MEMS based, then that means that it will use a micro machining technology. So when it comes to micro machining, what kind of things we use? We use bulk micro machining. We use surface micro machining, right? So this is already we have taught in this particular course. And when I say we, because I always involve my teaching assistants, so it's a group effort for any course to be successful. Now let me take questions which I got through NPTEL forum for this particular live session. The first question is asked by Anuj Kumar Goel, and Anuj is a faculty. So the question is, can I visit respective research labs related to MEMS and microsensors in Indian Institute of Science, Bangalore? The question is a little bit trickier to answer. However, let me put in this way: every faculty, every lab has a faculty who is associated and in charge of that particular lab. And the best way to approach would be to send an email to that particular respective faculty. There are few laboratories in the institute which works on MEMS-based sensors. One, of course, is mine. There are some in IAP, with Instrumentation and Applied Physics. There are many in SENSE, which is Center for Nanoscience and Engineering. In fact, we have the SENSE as a mother facility or nanofabrication facility, and a lot of time we very generously allow students to visit that facility. So that is the answer to your question, Anuj. Let me take the second question. Second question is asked by Ashish, and Ashish Tiwari is a faculty. And the question is, what preparation I need to do for online exam? Though I have studied almost all the videos, but is it enough to crack the online test? Please suggest. Ashish, the questions or the paper that we set is not to give you or any of students who take the exam a difficult time. It is just to understand how much you learn from this course. Okay, so the questions would be extremely simple if you look at this when you appear for the exam, and it's an objective type test. So if you go through the lectures, you go through the assignments, it will be very easy for you to answer and crack the test very easily. Let me take a question which is asked by Himanshu right now. Why silicon is best for MEMS? Himanshu, I started with explaining about MEMS-based fabrication, and MEMS-based technology requires a micro machining technology. So micro machining is where you work on bulk and surface micro machining. If you use silicon, there is a process already established. The recipes are already there. Like for example, wet etching, you use KOH with potassium hydroxide, TMH, tetramethyl ammonium hydroxide. You use it for dry etching, RI, reactive ion etching, chlorine based or fluorine based. We use DRI, the deep reactive ion etching, for silicon etching. So every process is set for silicon, and that's why at micro level, if you want to etch a silicon wafer, it is very easy, and that's why silicon would be or actuators in the MEMS. MEMS by actuators, then you can use silicon as a substrate, because again the fabrication process is very well known. The recipes are clearly mentioned and easy to fabricate. Another point is silicon is available in abundance, silicon dioxide in fact, and on the same silicon wafer you can have many sensors, so the cost will come down tremendously. People have started using different substrate for its own properties which are better than silicon, but at least as far as the MEM sensors are concerned, we generally prefer silicon. We can also use glass, we can also use the polymer for flexible MEMS, but still 90% of the techniques are based on the silicon material. All right, let me take another question from Ashish Tiwari, the same person who asked about online test cracking. I'm willing to visit IISc Bangalore to see fabrication process. I have started my research in MEMS and very much keen to understand the fact behind this technology. Is it possible for me to go there in your lab and visualize the reality? Yes, there is a possibility. Given that you give us enough amount of time for you to visit here, that means that you should tell us when you are going to visit, what time is appropriate for you. And see, there are about through 2,500 or 3,000 students who have registered, and to have all of them in the clean room, then clean room will not be any more clean, right? However, if you are visiting to Bangalore and you are really keen in looking at the lab facilities, then you should not only visit my lab, but also you should visit the another labs in the institute. You should visit the nanofab fabrication process facility, and they generally allow visitor to look at the facilities. So you send an email when you are going to visit, and we will reply to you so that you can your visit can be facilitated. Okay. The next question is Ganesh Kalagi, and Ganesh is a faculty, and the question is on fabrication process. I don't understand what is the question. You the question the only uh, there are only two words in the question: fabrication process. So Ganesh, if you can elaborate, if you are online right now, of what exactly you want to ask me in fabrication process. Okay. So the next question is from A Sai Nikhil, and is a student. Um, he is asking, A Sai Nikhil is asking more cancer diagnosis techniques, sir. See, there are 30 hours which are limited for this particular course, and I have in particular tried to put lot of techniques which, if you start working, you can get PhD out of it, right? It's not just like some course which is there in the theory and I'm repeating in a NPTEL platform. Some of the techniques that I am talking to you are not there in any of the courses, in any of the books also. All right, this is actual application of the sensors of the medical devices in a clinical perspective. So the beauty of this is, if you take up topic, if you go in depth, it is worth getting your PhD thesis. So I don't think I can just keep on getting you more and more innovative ideas, because this course is being taken up by a lot of faculty members, lot of students. So I had to be a little bit restrictive on applying the techniques for several diagnoses. However, just to since you have asked, let me give you one more example. You can use the MEMS-based VOC sensor for breast cancer diagnosis. It is to understand the signature of the breath, and from the signature you can design a screening platform for breast cancer diagnosis. Okay, let me take another question. Any other course in session January to April 2020? There are two rerun course. I am not taking any new course right now. I will be taking probably in July to December, or August December, this July 2020 session. I'll take a new course, but we will have two rerun course. Okay, relation between bandwidth response time of a smart material. I don't think that we have talked about smart materials in this particular course. And what exactly you mean by bandwidth response time, bandwidth and response? See, the response time, if you talk about sensor, like for example, the sensing material that we used in a sensor are nanostructure metal oxides, and the bandwidth is where you start the response time. When you reach the 90% of the saturation time, that is called your rise time, and your when you reach to 10% of your fallback time is your fall time, and that will be your bandwidth. The faster response time also depends on the structure of the material, and yeah, we use generally nanostructural material instead of the thin film. The reason being that the surface to volume ratio will be extremely high. Higher the surface to volume ratio, higher will be the sensitivity. The another point is that the desorption rate is very important when you talk about VOC sensors, because if you don't have a good desorption time or fast desorption time, the response time of the sensor would be fast, but while coming it back to the base resistance, it will be really slow. So that depends again on the material to material, but there is not any particular equation that we can fit in for smart materials. All right. Okay, so let me ask answer to another question from J Saranya, and Saranya is asking that whether catering facility is there at IISc and for performing CV study, and also just a second. Yeah, and also thin film study CV characteristics. So yes, there are already techniques available and technologies available in IISc to perform the CV study. You need to contact Sense facility for that. Now, as far as the Okay. So the next question, let me take the next question. The next question is from Rupa Mahesh. Can you please tell about chemistry of plasma bonding? Yeah. So see, plasma bonding works on the bonding between a polymer and the glass surface. So when you put in the oxygen plasma, then there are the activation sites which will help the polymer to bind with glass, and if you just Google it down, it will tell you the real reaction sites, the real chemistry. So I don't think we went into deep science about how the plasma bonding will work. We just told you about how the equipment you can use it for bonding glass to PDMS. So Rupa, easy way is because I am not a chemist, so for me to give you chemistry will be difficult. What I can give you right now is there are enough reaction sites that are created because of the bonding between glass, for bonding glass and PDMS when you load in plasma. Also, it depends on the power that you use, from 100 to 300 watts, milliwatts, 100 to 300 watts, not milliwatts, and also the concentration of the oxygen gas inside the system. All right. So I believe that if you just Google it down, you will have more understanding about the surface chemistry. However, also there are like several theories that when you do the plasma bonding, there are free radicals that are created, which leaves behind the bonding sites, and that will help to bond it in a better form. So that is what I can say right now. Chemistry is a little bit difficult and off topic for me to answer the question. Okay, I'm ready to take any other questions if you have. So as far as the exam is concerned, exam is of objective types, simple questions, and if you focus thoroughly, you can score well. The one thing that you need to understand from this particular course is no problem, Rupa. I'm glad that you asked. The only thing is, as you are a polymer scientist and I'm a microelectronics engineer, a micro engineer, with my study in electronics, it is difficult for me to answer the question that you asked. Okay. Okay. So, Himanshu, I don't get it. What radical material? Okay. So anyway, the point that I was making is that the course exam itself is very very simple. It is more from the classes that I have taught, some from the assignments and some from your own thinking. Now let me give you a few examples so you can have better understanding. Suppose I ask you that, okay, we are using the bulk micro machining technique, and I want to etch silicon about 400 microns out of 500 microns thick wafer. Then which technique you will use for getting a clear um, edges? Will I go for KOH? Will I go for TMAH? Will I go for RI chlorine? Will I go for RI fluorine? Or I go for DRI? What you will select? Hmm? So take it from that perspective. It will be easy for you to understand. DRI would be used, right? When you talk about wet etching, KOH and TMH, like I said, each of the chemical has its own benefit. For example, if you use potassium hydroxide, which is KOH, the etching of silicon is faster. But when you talk about TMH, the etching of silicon is slower. However, the surface roughness in KOH is more. Surface roughness of TMH is less. The KOH we have to use at 80 degrees centigrade. TMH we have to use at 25 degrees centigrade. So these are all the pros and cons. There is another question which is on how can we use microfluidic chip for screening drugs. I think I have already taught this thing in the course, and in the course what we have seen is when you design a chip, if you load the cells with matrigel is nothing but your extracellular matrix onto the platform or inside the well, where the bottom of the well has the interdigitated electrodes. Then what you do, you have to flow the drug next to it. Now, when you flow the drug, the size of the micro channels are such that it will mimic the in vivo situation. Again, let me explain you. In vivo is within the body. Ex vivo is outside the body. In vitro is the platform that you developed and you design this tissues or cells that you load in the platform. All right. So there are three different classes. Now, when we talk about mimicking in vivo situation onto the in vitro platform, that means that we have to understand that how the drug flows, how it diffuses, that kind of stuff. Okay, we have about if you design the microfluidic channel with 100 microns width and about 100 microns depth, then you can flow the liquid at 1 to 2 microliter per minute, or the liquid is your media, and that will mimic the actual in vivo situation. So when it diffuses through the matrigel, the cells would lyse. When cell lyses, conductivity increases and impedance would decrease. If you have three different channels, you can test three different drugs and you can get which drug is more effective by looking at the impedance value. Okay, let me answer another question by Rupa. Rupa, Rupa is asking how many questions will be there? Is it 100 numbers? We have asked 50 questions for 100 marks. So that is the answer. 50 questions. MCQs. You have multiple choices. Okay. So if you have any questions, please ask me. Uh, if you don't have any questions, then we will just stop our live sessions here. So, but like I said, no textbook will tell you. Uh, Textbooks will help us to understand the process. Textbook will also help us to understand the equations, the physics behind it. But textbooks will not help you to formulate a problem or find a particular application. All right. So my focus in this particular course was to help you. If you know the fabrication process, if you know how to design a sensor, if you know how to design biosensors, design MEMS based sensors, design biomems, right, or actuators, how can you use it for clinical perspective? What kind of different technologies that you can apply for, right? So that was the main reason of this particular course. Okay, let me take the next question. Can you give formula regarding resistivity and temperature? Sure, it's very simple, Saruk. The equation is of resistance R equals to rho L by A, right? So in that case, if you see, rho will be what? Rho will be R A by L, right? So as the temperature increases, the resistivity would increase if it is case of metal. Right. So that's how the relation between resistivity and the temperature is. I hope I can answer your question, Saruk. It's very simple. Resistivity and temperature equation. How you relate it. For metals and conductors, whenever you increase the temperature, the resistivity would increase. You understand, right? Like for resistance, R equals to rho L by A. So resistivity will be rho equals to R into A by L. L is your length, right? R is your resistance. A is your area, and rho is your resistivity. So now the resistance of the conductor or metal will increase when you increase the temperature. So that means that rho equals to R A by L. If resistance increases, resistivity also increases. So that's how it works. Okay, so I believe that there are no more questions. If there are no more questions, then we can end our live session here. However, if you want to ask me any more questions, I am still available for another 2-3 minutes. If you don't find any questions, then I wish you all the best for your exams, right? And I wish all of you a very happy and prosperous Diwali. Enjoy your time with your family, right? Research is one part of life. Enjoy research as well. Enjoy course and learning of courses through this NPTEL platform, right? But also spend some time with your loved ones, and do well in your exam. Exams are very very easy to crack. Don't take any kind of burden of clearing an exam. If you know the subjects, if you understand the topic, it's very very easy to clear the exams. All right. Sure. If there is if see, not everything would be mentioned in the videos. So some things we expect from a student to think and answer, and that's why the assignment questions are something that you need to find out how this Fourier series formula would be there or can be used for finding the thermoconductivity. Then, if you're asking me a question, then it is I am solving your assignment, isn't it? Which I don't have to solve the assignment. I can only give you assignment, solutions are there. So try to solve by yourself. Not every assignment or every questions that we will ask you would be based on what we teach, okay? There are some things that you need to think by yourself. And this is what we expect from a student, to think by themselves and come up with a solution. Okay, so I wish you all the best, and I hope that you learn something from this course. Again, feel free to contact us through forum. Still, if you don't find Saruk the answer to assignments, once the assignment deadline is over, then we will be able to give you answers as well. Okay, but when the assignments are given, we don't give solution along with assignments. Assignments are supposed to be done by you. If you are still not able to solve it after the deadline, feel free to ask through forum. If it is too much pressing for you and you are not getting response from the forum, you are free to ask me through my email ID as well. There will be questions on thinking, not really detailed calculation. So don't worry about it. But some simple thinking is required to answer questions. Not too complex questions would be asked, Saruk. So don't worry, don't worry. Rather than you go in depth and learn if there are some questions in assignment like this, so it will help you to get more understanding about the subject. The subject is very vast. There is no the particular course that you will study and you will know everything. So there will be a lot of things that you will find out that you need to either learn through the videos or through assignments or through Google or through books. There are multiple platforms. However, like I said, if you are not able to find the answer and already the assignment deadline is gone, then you can ask us. We'll help you out. Okay, so I'll see you all in some other course. Till then, you take care. Bye.